Hi, in this example, we're going to discuss a quadratic model with regression. Given in the example is the percentages of police officers who are women listed in the table for various city populations. So here are the intervals in the first column. The second column are the midpoints of each of these intervals. And then the last column is the actual percentage of women who are police officers. Let f of n be the percentage of police officers who are women with populations of n,000. A model of the situations is f of n equals 0.00006n squared plus 0.012n plus 7.884. Use a graphing calculator to draw the graph of the model and in the same viewing window the scattergram of the data. Does the model fit the data well? So let's go ahead and go to our graphing calculator and put this information and into the calculator and graph it. So we can see that we're going to have two columns here, a list 1 and a list 2. So going to our calculator, you'll hit Stat and go to Edit, and you'll see some lists here. Yours might be empty. So the first list will be those midpoints, the second column here. The second column is the percentage of police officers that are women in a particular city. And then you would go to second y equals, which will give you stat plot. And you're going to turn the plot on. So hit enter and it brings up a new menu. Go ahead and hit on. When you hit the arrow down, notice you have 6 graphs to choose from, but we're going to choose the one that looks like a scattered dots. List 1 will be the second column, right, the population, and the list 2 are those percentages of women that are police officers. You can choose your marker. I usually choose the first one, and then you can also choose the color if you need to, if you have a TI-84 plus CE. At this point, we would go to graph this, to zoom, and then notice number 9 is zoom stat. It does this on purpose so it can beautifully graph the scatter plot. So each of these points are a point on this table, like this is the x and this is the y, x, y, x, y. And looking at that scatter plot, you would want to see whether or not it would take the shape of a quadratic function. So in order to see if f of n is a good model for this data, so is f of n good for this data? The best way to determine this is to actually just graph the function itself. So let's go ahead and put f of n in the calculator. So now we can go to y equals, and we'll put 0.00006 squared plus 0.012x plus 7.884. Now I know I'm using x's instead of n's only because the variable button, which is to the right of the alpha button, only allows x. But we know they're n, but all we need is the graph. So let's double check. 406 n squared, 0.012, and 7.84. All right, let's go now back to graph and see how this model fits the data. And we can see that that model definitely fits these data. Okay, so I transferred the graph over here and we can see that this definitely fits the data beautifully. All right, so the answer to the first question is, does the model fit well? Yeah, it is a good model. Glen Ellen, Illinois has a population of 117.61 thousand. Estimate the percentage of police officers in Glen Ellen who are women, and round to one decimal place. So notice they're giving us a population. So N is the population and F is the percentage. Because this model F of N fits this data so well, we are able to predict values for other populations within the scope of the model. So we just want to make sure that if we want to find the percentage of women that are police officers, that we are within 5 to 300,000, just within the scope of our model. This is easily done by plugging and chugging. So if we're given the population of 117.61, I'll put that right into my model given. And we could do this by hand, or we could utilize our graphing calculator. And then plus that 7.8. We can utilize the graphing calculator. So if we come back to the calculator and we set our table, so second window would give us table set, and make sure your independent is on ask, we can easily go to second graph, which is an empty table, and ask it for 117.16. So if the population is 117.16, the percentage of women that are police officers in that city is 10.1. When I want to find T, when f of T is 12, then I would have to do a little bit more of algebra. So for example, if I have f of T equal to 12, what they really want is for us to plug in 12 equal to 0.00006 n squared plus 0.012 n plus 7.884. So if I go ahead and set this equal to 0 and move over 12 to the right side, I get, so you would go ahead and use the graphing, the quadratic formula and have negative 0.012 plus or minus the square root of 0.012 squared minus 4 times A, 0.0006, times C, which is negative 4.116. And this is all over 2 times A. So after you simplify that, you should get, rounding to the first decimal place, approximately negative 380.4 and a population of 180.4. So going back, the population, when the percentage of women is 12%, is either down 380.4 or up 180,400. So when it's asking for f of t equals 12, it's saying that if the percentage of women is 12% that are police officers, then what is the population? And that population is down negative 380,400 and 180,400. So then we said the next question is, what does it mean in this situation? Well, down here when it has the answers, it says 12% of police officers in cities with populations of about negative 380,400 or 180,400